Imagine processing $250 billion.
Oh, man.
Yeah, $250 billion in financial contracts every single year.
It's almost impossible to even picture that amount of money.
Right. Now imagine taking the root access keys to that massive hypercritical infrastructure and just handing them over to a brand new junior developer on their very first day at the company.
Yeah, that sounds absolutely terrifying.
It really does. But the crazy thing is, right now, across the tech industry, that is essentially what executives are doing with AI coding agents.
Exactly. It's basically a massive vulnerability disguised as an efficiency hack.
Yeah.
Because there's this incredibly seductive promise out there right now, right? This idea that you can just install an AI plugin, flip a switch, and suddenly your engineering team is doing the work of a team 10 times its size.
Which is the exact mental model we are going to completely dismantle today. Because for you listening, we're diving into a really brilliant opinion piece.
It's so good.
It really is. It's from CIO, published on April 23, 2026. It's by a contributor named Mike Wilkes. And the title of the piece really captures the whole mission of our deep dive today. It's called, "Your AI Coding Agent Isn't a Tool, It's a Junior Developer. Treat it like one."
And that framing changes everything.
Completely. Our goal today is to look at why treating AI as this, hyper-fast, autocomplete, this thing the industry is affectionately calling vibe coding, why that is a one-way ticket to catastrophic technical debt.
Oh, absolutely. The technical debt is real.
It's massive. And we're going to look at the management shift that's required to actually unlock the real productivity gains everyone is chasing.
So, okay, let's unpack this. Where do we even begin to reframe how we look at AI in the engineering stack?
Well, I think we have to start by establishing what actual high-stakes engineering looks like. And Wilkes does this perfectly by sharing a story from his own career.
Right, his time in DevOps. Yeah, during his time working in DevOps, he was at the CME group. And for those who aren't familiar, CME operates some of the most critical financial infrastructure on Earth. I mean, they process that $250 billion worth of contracts we were just talking about.
A quadrillion with a Q. I have to pause there because that is a level of scale that is so hard to wrap your head around. It's not just a big number,
No, it's not.
It means if that system goes down for even a minute, global markets panic.
It is the literal definition of critical. CME is what's known as a SIFI.
C5.
Yeah, SIFI.
Yeah.
A systemically important financial institution. When Wilkes was there, they were running across 5 data centers.
Wow.
Over 10,000 servers. And they were managing these massive racks of Oracle Exadata systems.
Oh, Exadata. Those are the heavily optimized ones. Yeah.
Exactly. Extremely expensive, highly optimized database machines designed to handle just insane transaction loads. So as you can imagine, when you get hired into an environment like that, you obviously do not get the keys to the kingdom on day one.
Right. You don't just log in and start blindly executing commands.
No, any mature engineering culture is going to pair you with a mentor.
Because at that scale, one type of, literally one wrong keystroke could cost millions of dollars in a fraction of a second.
Or entirely crash the global commodity markets. So Wilkes was paired with this deeply technical manager named Matt. But the interesting thing is, Matt didn't just hand him a manual of commands to memorize.
Like a cheat sheet or something.
Right, no cheat sheets. Matt's job was to act as a docent for the infrastructure. He essentially taught Wilkes how to interrogate this massive system of systems. He taught him how to ask meaningful questions.
Okay, wait. What does a meaningful question actually look like at that scale? Because I imagine it's a little bit more complex than just pinging a server to see if it's awake.
Oh, far more complex. Yeah. Because when you manage infrastructure at the sci-fi level, every single query you run might return 10,000 lines of logs.
Good.
Right. So you have to know what actually matters. Matt taught him to ask things like, are the SING groups configured properly for workload isolation?
Meaning what exactly?
Meaning, if one rogue script just goes crazy and starts eating memory, is it walled off? Or is it going to suck up all the server's RAM and crash the matching engines that are handling the actual multi-million-dollar trades?
Yeah. Okay, so containing the blast radius.
Exactly. He also taught him to check things like the RAID arrays, like are they starting to show underlying drive failures before a disk actually physically dies?
Right.
He had him verifying if the firmware and the BIOS versions were perfectly aligned across the production and QA environments. Really, really detailed stuff.
So it's not just about knowing the syntax to run a quick system check. It's about knowing the incredibly specific ways this particular beast of a system tends to break.
Yes. And Wilkes makes a great point here. He points out that this lesson was essentially epistemological.
Epistemological. That's a big word for a tech deep dive.
It is, but it fits perfectly.
Mm-hmm.
Epistemology is just the study of knowledge, how we actually know what we know.
Yeah.
And engineering expertise is highly epistemological.
Okay, how so?
Well, it is about knowing which questions actually matter in your specific context. And then once you ask the question, having the deep, hard-won understanding required to interpret the response.
Right.
And you only build that epistemology through, narrow maintenance windows at 2 in the morning.
Ugh, the worst.
Yeah, by doing dry runs, preparing rollback plans that fail, grinding through the ticket queue over years and years.
So if I'm translating this to the AI discussion, if you treat a large language model like a simple tool, it's almost like hiring a brilliant translator who has memorized the entire French dictionary, but they've never actually been to France.
Oh, that's a great analogy.
Like, they can write a technically perfect sentence, but they'll accidentally insult the locals because they have absolutely zero understanding of the cultural context of what they are saying.
What's fascinating here is how clearly that maps to the architecture of AI. We fundamentally misunderstand what these models actually are.
Yeah.
Wilkes describes an AI coding tool as a super smart baby.
A super smart baby. I love that.
Or, you could think of it as a recent college graduate who just drank way too much coffee.
We've all worked with that guy.
We all have. And look, they have ingested a massive amount of training data. Yes, they've read all the books, but they are entirely lacking in lived experience.
Right.
They have zero hard-won lessons in release engineering. They do not know the physical pain of debugging a race condition in the middle of the night.
Oh, man. The 2 a.m. pager duty.
Exactly. They have no contextual wisdom.
Which, ironically, is exactly the profile of a human junior developer. Eager, incredibly well-read, and highly likely to break production if you leave them unsupervised.
Totally.
Yeah.
And because AI lacks that lived experience, when it tries to write code in the real world, it fails in very predictable ways.
Okay, what kind of ways?
Well, Wilkes actually ran an experiment to demonstrate this. He was working alongside a coding model on a real-world security problem. The task was pretty standard. He needed to harden an API and application programming interface to produce a transparent security uplift.
Right.
But there was a critical catch. Because he's in finance, he needed to do this without adding any latency or complexity on the client side.
Oh, right, because in a financial setting, if your security protocols add even like 5 milliseconds of latency to a trade,
It's over.
yeah, your application is useless. The high-frequency traders will just abandon it.
Exactly. Speed is everything.
Yeah.
So when he gave this prompt to the AI, the model generated code suggestions incredibly fast. But the speed itself was actually the problem.
Really? How so?
Because an LLM is ultimately just a token prediction engine. It doesn't have true situational awareness. It predicts the most likely string of code based on its training data.
Right, which is just the entire internet.
Yeah, and the internet is full of outdated Stack Overflow posts and deprecated open source repositories from 10 years ago.
Yeah.
So while the code it spit out for Wilkes was technically plausible in a vacuum,
Like it compiled?
but it compiled,
Right.
but in a real-world operational environment, it was functionally obsolete.
So it basically just glued together pieces of syntax that statistically look like a security patch without actually knowing if those patches work in the year 2026.
Spot on. Furthermore, the AI completely ignored the non-functional requirements.
The latency stuff.
Yeah, the latency and the compliance rules. It surfaced relevant information, sure, but it had zero judgment. And the most dangerous part of this whole interaction is that the AI has a fundamental architecture bias. It accepts the legitimacy of your ask.
Meaning it assumes whatever I happen to type into the prompt box is a brilliant idea.
Yes, it never questions your baseline assumptions. If you go to a human senior engineer and request to harden the API, they might look at you and say, why are we even trying to do it at this layer? That's the wrong approach entirely. We need to handle this at the load balancer.
Right, a human pushes back.
And AI won't do that. It will just try to solve the prompt, even if that means literally hallucinating a non-existent software library to magically bridge the gap.
Okay, but why exactly does a human know to push back while the machine just blindly follows orders? Like, what is the actual mechanism making the human smarter in that scenario?
So information scientists explain this using something called the DIKW pyramid.
DIKW.
Yeah, it stands for data, information, knowledge, and wisdom.
Okay.
Think about a specific coding scenario, like a database timeout error.
Sure.
The raw error log you get, that is just data.
Just text on a screen.
Right. But when a human developer realizes, hey, that error spikes at 9:00 a.m. every single day, that becomes information.
Ah, a pattern.
Exactly.
Hmm?
Then when they dig in and figure out it's happening because of a massive batch reporting job that's locking the database tables, suddenly they gain knowledge.
Okay, so data to information to knowledge. What about wisdom?
Wisdom, the very top of the pyramid, is when that developer architects the next system to decouple the reporting from the transactional database entirely, so the problem simply never happens again.
That's fascinating. And a human only really gets to that wisdom tier by going through the pain of the database crashing at 9 more 0 a.m. for 3 weeks straight.
Yes. Humans struggle their way up that pyramid. We try things, we fail, we feel the stress of a broken system, we get yelled at by clients, and we iterate. That messy struggle is the crucible, where knowledge actually gets refined into wisdom.
Right.
AI models do not experience struggle. They skip the process entirely and jump directly from data to conclusions.
Here's where it gets really interesting, though, because I hear what you're saying about the messy struggle.
Yeah.
But if I'm a CTO and I'm looking at my budget, I'm thinking, I don't have time for my senior devs to babysit an algorithm. I'm paying for speed. If treating the AI like a junior dev forces us to slow down and struggle alongside it, doesn't that completely defeat the entire ROI of dying the tool in the first place?
That assumption is the trap. It really is. You have to separate tools from developers.
How so?
Think about a hammer. A hammer is a tool that doesn't need judgment.
Yeah.
Right? It doesn't need to know if you're building a house or carrying one down.
It just hits the nail.
Exactly. But a developer, even an artificial one, is making logic decisions. It requires judgment. If you skip the messy struggle of code development and just let the AI rip, you aren't actually saving time.
What are you doing then?
You are simply shipping vulnerabilities faster than your security team can ever hope to triage them.
Wow.
You are automating the mass production of technical debt. And eventually, that debt will paralyze your entire engineering team.
So if these models are inherently prone to, confidently writing deprecated code and skipping the struggle means we just drown in technical debt, how do we actually manage them?
That's the million-dollar question.
Right. Because you mentioned earlier that human junior devs have the exact same lack of context.
They do.
So how does a company deal with a human junior dev without breaking the system? And can we actually map that onto an AI?
Well, earning trust takes time, right? Whether you are carbon or silicon.
True.
Think about your own job for a second. Think about the weird, undocumented workarounds you use every day that took you 3 years to figure out.
Oh, yeah. The duct tape holding the servers together.
Exactly. A new human hire dropping into your workflow doesn't know about any of that duct tape. You don't trust them to push code independently for months.
Definitely not.
You build trust progressively by observing them. You look at things like, how do they document their changes? Do they write robust tests? Do they anticipate edge cases before they happen? Wilkes points to the famous Netflix manifesto from back in 2001.
Oh, I heard of that. Yeah.
They operated on this core philosophy of 100% freedom and 100% responsibility. Engineers there act like true owners, and management tracks their progress by looking at their operational discipline over time.
Okay, so we basically take that exact same progressive trust model and apply it to the AI coding agent.
Yes, you start small. In the very first phase, you only let the AI agent propose little code snippets, isolated stanzas, and a senior engineer reviews them carefully.
Like peer review.
Exactly. And if the AI adapts to corrections well, then you promote it to the next level. Now it can draft entire functions or package internal libraries.
Okay, moving up the ranks.
Right. And only after it is proven over a long period of time that it understands your specific architectural quirks and your company's specific risk appetite, only then do you let it implement entire features.
So it basically has to earn its root access, just like Wilkes had to earn his at the CME group.
Exactly the same way. But there is a crucial second layer to this training process that we have to talk about. Wilkes introduces this concept of learning from multiple chefs.
Multiple chefs. Let me guess, this is about making sure the AI doesn't just learn one person's bad habits.
It is, but it's even broader than that. Look at Wilkes' own resume. He started in San Francisco during the dot-com era.
The Wild West.
Yeah, and that environment taught him all about speed, agility, rapid experimentation, move fast and break things.
Right.
But then he moved into trading infrastructure in European financial markets. That is heavily regulated.
Very different vibe.
Completely different. That environment taught him rigorous project governance using strict frameworks like the Prince2 methodology. And then later on, he worked with large-scale commodity exchanges, which embedded this deep, deep understanding of operational resilience.
Okay, I see.
Every single environment he rotated through profoundly reshaped how he approached engineering.
So relying on just the AI's base training is kind of like an aspiring chef only ever reading one massive, totally homogenized recipe book.
Yes.
Like they might know the technical textbook definition of a souffle, but they need to cook in different actual kitchens under different head chefs, a fast-paced bistro, a Michelin star restaurant, a massive banquet hall to actually understand the art of a meal when the pressure is on.
If we connect this to the bigger picture, that is exactly why you have to rotate your AI agents among different senior engineers within your organization.
Yeah.
Because if an AI only works with one developer, or worse, if it relies entirely on its base training, which, remember, is just token prediction algorithms trained on billions of lines of generic internet code.
A slop.
Yes, the slop. It is going to produce homogenized generic work. But by pairing the agent with multiple senior engineers over time, you expose it to different architectural philosophies,
That makes total sense.
different debugging styles, different security mentalities. You literally teach it the nuanced best practices of your specific organization.
I love that idea. The AI is doing rotations, almost like a medical resident, moving from the ER to cardiology to neurology, so they understand how the whole hospital functions, not just one isolated ward.
It's exactly like a residency.
But okay, we really need to address the elephant in the room here.
Let's do it.
We're sitting here talking about careful mentoring, progressive trust, and cross-team rotations. But if you look at the executive level right now, that is not the conversation happening in the boardrooms.
It is absolutely not. And this is where Wilkes pivots to issue a very stark warning for CEOs.
Chief Information Security Officers.
Yes. Right now, security leaders are under immense, crushing pressure from executives to slash their developer headcount. The executives are looking at the glossy demos for these AI tools, and they're just assuming the AI can simply absorb the workload of the humans they want to lay off.
So what does this all mean? The executives don't care about the epistemological lesson, right? They just want to cut costs. If they view the AI as a magic switch that completely replaces humans, how does an engineering team actually push back against the kind of top-down financial pressure?
You have to speak their language. You do that by demonstrating the rule of amplification.
Amplification.
Yeah, AI does not create a culture. It only amplifies the existing one.
Oh, wow.
If an organization has incredibly strong security discipline, well-documented architecture, clear coding standards, mature human review processes, then integrating an AI agent will amplify that good culture. It becomes a massive asset.
Right.
But if you have weak security habits, poor documentation, and a culture of cutting corners,
The AI will amplify those weaknesses, and it will just churn out garbage at machine speed.
exactly. Wilkes uses this brilliant metaphor to explain this to leadership. He says, human knowledge is like sunlight. Large language models are like moonlight.
Sunlight and moonlight.
Yeah, LLMs are merely a reflection of that human knowledge. You cannot build a thriving, growing ecosystem entirely under moonlight.
The plants will just die.
They will. You need the sun. To push back against executives, you have to prove the compounding payoff of the mentorship model. You show them that treating the AI as a collaborator, literally sitting down and telling it stories about how your team isolated a bizarre bug that took weeks to pinpoint that, is what transforms the AI from a dangerous novelty into a genuine multiplier.
You're saying we have to prove that the ROI only exists if the senior humans are there to guide the machine.
Yes.
Because if you fire the senior engineers to pay for the AI, you are essentially firing the sun to save money and just praying the moon will keep the crops growing.
And you will starve. The multiplier effect that executives want, it is real,
Yeah.
but it only happens when the sun is shining on the system.
Okay, bringing this all together. The source material is presenting us with a very clear, ultimate binary choice. If you treat your AI coding agent like a disposable tool, like a fast autocomplete defeller, you are going to get disposable code.
Yep.
You're going to get slop, and you will bury your company in technical debt. But if you take the time to treat it like a junior developer, if you really invest in the pair programming model and expose it to the messy reality of your specific systems, you might just raise up the most powerful engineering partner you have ever had.
This raises an important question, though. One that really lingers when you look at the whole picture over a longer timeline. Well, we just established that AI models absolutely need human wisdom to function safely.
Right.
So if we rely entirely on our current human senior engineers to pair with and mentor these AI junior developers, and we simultaneously use those AIs to replace human junior developer roles to save headcount,
Oh, no.
Where exactly will the next generation of human senior engineers come from?
Wow.
If humans absolutely require that messy struggle up the DIKW pyramid to gain actual wisdom, what happens to our entire technological ecosystem in 10 years when only the machines have been allowed to practice?
That is a deeply chilling thought to end on. We all wanted a magic wand, and we might accidentally be coding ourselves out of the very messy struggle that makes us experts in the first place. Thank you for joining us on this deep dive. For everyone listening, the next time you're looking at rolling out a new AI tool, take a second to think about how you're onboarding the super smart babies in your own organization. Are you just flipping a switch and hoping for the best, or are you actually ready to mentor them? We'll see you next time.